All right, so in 11.6, we're going to talk about two things. So I'll probably make two videos, but probabilities involving not and probabilities involving or. Let me change that too. So it's not too confusing. Probabilities involving not and probabilities involving the word or. So you'll see what I'm talking about. So first we're going to talk about the probabilities involving not. Okay. So the way to kind of introduce this is as follows. If we know there is a 60% chance of rain tomorrow, then my question is, then what is the chance of not raining tomorrow? Well, I don't think we really have to do any kind of work on this one. If we know that there's a 60% chance of rain tomorrow, then that means that there's a 40% chance that it will not rain tomorrow. So 40%. All right, so yeah, that's pretty straightforward, and I got a point to this. So here's what I want to say. The probability, let's do it this way. The way we got this 40% is I said 100% minus the probability that it would rain, and that was the probability that it would not rain. Okay, so that should make sense. So let me write something more general for our notes. So if we denote the probability of an event happening as E, or actually, since we're talking about probability, we're going to call it the probability of E, then the probability of an event E not happening is probability of not E is 100% minus the probability of E. Or we could say instead of percentages, we could use 1. So the probability of not E is 1 minus the probability. Okay, that's how we're going to see it more in the homework. But I started off with the percent because that was probably more obvious. And also, further, the event not E, so in the situation where not E happens, this is called the complement. of E. Okay, so the probabilities involving not, some books will call that the complement. What is the probability of the complement of something? All right, so here's an example, pretty straightforward. So we'll do this, and this is going to wrap up this video. So let's say if you are dealt one card from a standard deck of 52, and what I mean by that is hearts, clubs, spades, diamonds, the same ranks as we had mentioned before. So let's say we were dealt one card from a deck of 52. Find the probability that the card is not an ace. Okay, so I take my deck of cards again. And so in this example, a success is not an ace. Okay, so let's start counting. So I got my cards out. So not an ace. 1, not an ace. 2, 3, 4. Well, it looks like I'm going to be here all day going through this deck trying to find not aces, right? So rather than adding up all the not aces, let's figure out how many aces there are. You probably know that. There are 4 aces. I'll find them all. I got them here somewhere. Looks like I'm missing ace of clubs. There it goes. Okay, so I got all my aces. So there are 4 aces. So the probability of not choosing an ace, it would be quicker to do the following. The probability of not ace is equal to 1 minus the probability of an ace. Okay, so 1 minus the probability of an ace. So how do I find the probability of an ace? Well, there are 4 aces in the deck of 52. So this would be the easier way to go about it. Now I could type this in the calculator. I could do common denominators, so I'll do that in a second. 1 minus 4 divided by 52. I get a decimal, second PRB, and I get 12/13. So 12/13. If I wanted to find a common denominator, I could. Let's see, common denominator here, I'll do it by hand. That was something else. Okay, that would be 52 over 50, 52 over 52 minus 4 over 52. And then 52 minus 4, I can now combine those because our denominator is the same. And I get 48 over 52. I can divide both of these by 4. I'll get 12 over 13. So since you're required to have the calculator, it's probably safer to get the correct answer just to do what we did here. That is lazier, but at the end of the day, we want the correct answer. I will not be looking at your work on that. Okay, so we'll stop the video there. I'm going to do another one for probability using OR.